Pleasure for me today to welcome all of you to this webinar. I'm Catherine, currently the research head at Maritime Research Center. It is my privilege to welcome you all to this webinar on marine spatial planning through indigenous innovation and the live demonstration of shipping radiated noise tool, which has been developed by NirDhwani Technologies. I'm also thrilled to share that this is the first of the series of webinars we have planned to demonstrate the innovation aspects of UDA technologies by NDT. At the heart of today's discussions lies an urgent and pressing issue, the alarming rise in underwater radiated noise due to increasing maritime traffic, particularly in the Indian Ocean, one of the world's busiest trade corridors. In the past century, the proliferation of commercial shipping has led to a significant surge in underwater noise levels, disrupting marine ecosystems and threatening biodiversity. Studies indicate that low frequency ocean noise has increased by approximately 3 decibels per decade since the industrial era, with large cargo vessels generating about 180 to 190 decibels. This disruption impacts marine species who are reliant on acoustic signals for communication, navigation, and survival. For coastal communities and fisheries, this translates into tangible economic consequences with declining fish stocks and ecosystem imbalances. Recognizing these challenges at the global scale, global regulatory bodies such as the International Maritime Organization have introduced guidelines to mitigate shipping noise. However, comprehensive regulatory mechanisms are still absent under MARPOL, making it imperative for countries like India to take proactive measures through policy-driven technology interventions. For example, the energy efficiency existing ship index EEXI, which came into force in 2023, has offered an indirect pathway to noise reduction, but a more integrated approach is still needed. So now this brings us to the role of marine spatial planning, a strategic tool for sustainable ocean governance. Effective MSP integrates environmental conservation with economic activities by leveraging policy interventions, technology interventions, and capacity building. I'm excited today to announce that MRC, along with NDT, have also been developing a comprehensive handbook on marine spatial planning, which is tailored especially for tropical waters. So, in this context, policies ensure sustainable use of marine resources. Technologies like shipping radiated noise tool and other automated monitoring systems provide real-time data for better decision making. And capacity building, which involves training, collaboration, and infrastructure development to equip stakeholders with the necessary tools and skills, all come together to make a comprehensive marine spatial planning. Together, these elements ensure responsible utilization of marine resources, balancing conservation with economic growth. So, with this background, the shipping radiated noise tool that we will explore today exemplifies how indigenous AI driven technologies and solutions can enhance our ability to monitor and mitigate underwater radiated noise in real time by leveraging aspects such as predictive analytics, machine learning, and computational modeling. This tool enables evidence based decision making for noise reduction strategies, ship design optimization, and impact assessment. So, India's commitment to self reliance in ocean governance aligns seamlessly with the broader objectives of the blue economy and sustainable maritime development. The deployment of AI powered technologies in maritime operations is not merely an innovation, it is a necessity for ensuring ecological resilience while fostering economic growth. So, by integrating advanced noise monitoring systems into MSP, we strengthen India's capacity to manage its vast maritime domain efficiently. So, I extend my gratitude to NirDhwani Technologies for spearheading this initiative and the distinguished speakers for coming together today to deliberate on this innovative development. UDA technologies are vital to this discussion And NirDhwani Technology, with its innovative technology-driven decision-making framework, offers innovative acoustic capacity building solutions to enhance maritime situational awareness. So encourage today all the participants to actively engage in the discussion, and let us work together to drive actionable insights and pave the way for future where technology and policy harmonize to protect our oceans while sustaining economic prosperity. As we move forward, let us focus on fostering partnerships between government bodies, maritime industries, and research institutions to establish a robust governance framework for underwater noise management. Thank you, and I look forward to an insightful and impactful session ahead. Sir, over to you. Thank you.
Thank you, Catherine, for a very comprehensive opening remarks. I'll not take too much time because I want our team to get more time who have really worked on it. So just to remind you of the UDF framework that we have been working on, and you can see the smaller cubes within the larger cube. And as Catherine mentioned, today's webinar is all about demonstrating the innovation that we have been working on, and that is towards building the larger MSP mapping. And in that, these smaller cubes will get populated as we keep progressing. And you will find that more and more applications will get covered. And today being the first one in this series, we have taken up ship radiated noise, but you'll also, every month you will see one such event where we will cover different aspects. And each of them you will also observe that there are multiple stakeholders who get addressed. I mean, as you know, UD framework is all about pooling of resources and synergizing of effort. How the same capacity and capability can serve multiple stakeholders is what we look at. So just to give you an example, what we are going to discuss today is the underwater radiated noise or ship radiated noise. Now, this analysis or this capacity building is extremely relevant to the Navy because acoustic stealth is a very important aspect. Ships have to be quieter, and ships have to also have very good detection capability. So in both of these cases, the mapping the ship radiated noise is very, very important. Having a better sense of what kind of acoustic signature each ship or submarine is making is a very, very important aspect as far as the naval deployments are concerned. So this kind of work is a very unique effort or unique innovation, which can have a lot of naval application. But another very important thing which is gaining momentum now is the acoustic habitat degradation. The International Maritime Organization has taken cognizance of the ill effects or harms of underwater radiated noise on marine mammals. And we are seeing large scale stranding across the world. And even in India, the western coast has seen a lot of such incidents, and these have really increased manifold. So shipping radiated noise is also a very big conservation concern. And there again, this becomes important. But we have to also see how our innovation can solve real world problems. But for the developing world, cost is also a very important factor. And then, of course, finally, on the ground, it's the ship designers and the ship builders who have to get the right kind of inputs to minimize the noise due to shipping. So there again, the digital tool will be very, very important. My colleague Sridhar, who leading this project, will be talking more on it. Similarly, you can see sediment management will be one of the topics going forward. I will not talk more on this. Now, the problem is that when we talk about the Indian EEZ, we're talking about 3.7 million square kilometers. How do we generate an MSP or marine special planning for such a big area is a very big concern. And the Global South cannot deploy so many sensors to collect the data. So here the modeling and simulation becomes a very important aspect. My colleague Sridhar will and his team will dwell more on this. But here again, this important part is that mapping the tropical condition or the source path receiver model is very important, where our team has done some very unique work. Now, having done the modeling and simulation, important aspect is the field validation. Here again, to see, to understand, and to share becomes a very important thing. To see is the sensor and the platform. So we have to deploy, but what will happen is through this modeling and simulation approach, we will minimize the deployment of sensors, which will substantially minimize the cost of such. I mean, these are called, I didn't talk about it, the shallow water acoustic measurement for the field validation. So cost effectiveness is a very important aspect, and processing. The kind of modeling we have done now, we can map the entire tropical waters of the Indian Ocean or even the Indo-Pacific with a lot of data which is available above water, like a lot of satellite data and various AIS data. So all that will be covered in our presentation today. And how to share is very important, because it has to be a user-friendly and real-time presentation of the actionable information. And every user, whether it is a policymaker, whether it's a stakeholder, or somebody on the ground who is deployed for taking action, they need very specific customized information. So how do we make it more customized is something we need to look at. And one important aspect is the manpower. I mean, in India, we have, or in this part of the world, I mean, the Indian subcontinent itself is 1/4 or the 25% of the global population. So meaningful engagement is another very important aspect. So there are three categories of manpower that will be required. I mean, high-end data analyst is one aspect. The second is domain knowledge. Once that data comes in, we need multidisciplinary experts to analyze that data, even including for policy, as Catherine mentioned, it will require people with liberal arts background also, or law background. And the third one, which I feel is the most important, is the field deployment specialist. Here, the local community becomes very important. Today, in the name of development, the local population or the indigenous coastal community becomes the biggest victim. Why can we not integrate them into this whole digital transformation process? So field deployment can be better done or best done by these local coastal and riverine communities. So a little bit of skilling for them, and how we can, and they can in fact bring in a lot of traditional knowledge. I mean, dealing with the waterfront, I don't think anybody other than them can tell us how to go about it. So I think my colleague will talk about, this is that AI-driven modeling and simulation approach that we have used. So I'll not spend much time. So this is the marine spatial planning that we call, which is nothing but a spatio-temporal mapping. And this map is temporally also updated very quickly. Those details will be covered, and you can see spatially we get this can be a very good decision-making tool, as Catherine mentioned, for the policymaker, how to contain. I mean, here we are not out to say that you stop shipping, but we can definitely, in certain ecologically sensitive period, we can definitely divert from certain sensitive areas. I mean, IMO does have a concept called PSSC, particularly sensitive sea area, PSSA. So their shipping is banned because of certain ecological situation. So, but that can be realistically done only if you have data like this. So how to do it, and there are certain seasonal issues also which can be so it can be far more precisely managed. So this is the larger marine spatial planning. So I'll not take too much time. So I hand over to Sridhar to take it forward. Thank you so much.
Thank you very much, sir. Thank you again for this opportunity to present the SRN tool, and welcome to everyone to this August gathering of people who are here to look at our demonstration of the SRN tool. As Catherine mentioned, we are trying to do this once in a month. So as we start this presentation, allow me to draw this inference as I'm making this presentation here today. Australia is gearing up for what is supposed to be a cyclone that hasn't happened for the past 3 decades now. A cyclone Alfred that's coming towards the coastlines, and it's supposed to hit sometime tomorrow or day after tomorrow. Now, the point I'm trying to make here is that with any kind of disturbance that happens, the importance of any kind of a modeling and simulation based tool, importance of any kind of a digital tool that allows us to pictorially understand what the real-time event is looking like is an extremely important aspect. With tools that for humans, for tools such as these, which predicts the extreme weather events, or which predicts how the movement of cyclone is happening and things like that. It allows us to respond immediately to any kind of threat. It allows us to prepare and save the communities as and when required in preparation of what is about to strike. But what about marine mammals? What about coastal communities? What about other communities that live near the seashore, and the problems that have been happening? It's not something that is immediate, but something that has been gathering for over decades and decades of time. Uh, every day, shipping traffic contributes to a rising underwater noise. Footprints that are disrupting our marine ecosystems, interfering with our communications among species, and even altering all the migratory patterns that are happening in the species. Now, the article on the left essentially is a stark contrast. This is an old article again from 2016, where more than 80 whales have beached on India's southern coast. And a lot of it is unknown, a lot of information about it is unknown as to what has caused this. But noise, a huge amount of noise pollution has definitely contributed to this, because when there's an increase in noise, these marine mammals cannot communicate with each other. They lose their ability to communicate because, again, sound is the only way for them to communicate. Light does not propagate underwater. So therefore, it is extremely important for us to have a similar tool, similar set of modeling and simulation based approaches that allow us to identify the changes that are happening to a habitat in real time. And the shipping noise, the low frequency, the shipping noise is predominantly uh, the most impacting noise at a low frequency range of 100 hertz to 500 hertz, and that is the same frequency range in which the marine mammals communicate, in the same frequency range in which most of our equipments operate, and so on. So therefore, it's extremely important to understand what we are actually looking towards. Now, ideally, when we look at any kind of traffic, when we look at the shipping traffic in Indian Ocean region, from an economic perspective, from a blue economic perspective, we kind of feel safe, and we feel pride in the aspect that the kind of shipping lane that we are forming. It's Indian Ocean region today is one of the most important sea areas globally. It is the focal point of both the maritime trade. It's a geopolitical hotspot, and most of the shipping traffic, international shipping traffic, does flow through this region, and that provides a massive boost to the economy. But then the picture that I'm showing here, sorry, the picture that I'm showing here, being generated from the tool that again Jay will be demonstrating, uh, showcases the alter side of it, in which the amount of noise that we are generating in the region because of this ship. So these yellow dots that you can see here are basically the ships that are moving in the region, and the color coded map represents the noise level in dB reference 1 micropascal. Um, so the problem statement is very clear. There is a huge amount of shipping traffic in the region. We'll talk a bit more about what kind of disruptions it is causing. But in terms of the existing methodologies, existing solutions that we rely on, most of these solutions are uh, estimation of cumulative long-term noise. What I mean by that is that we do not have a feasible solution, an economically viable solution that allows us to estimate the noise that is happening in real time. And therefore, that it basically fails to capture any kind of fluctuations that happen in the noise, and how the marine ecosystem will get impacted, how the naval operations will get impacted, and so on. So the point here is clear. The ocean is no longer silent, and all the existing methods that we have is not enough to deal with real-time challenges, and especially so for developing countries. As I mentioned, we have to also consider the economic aspect, that whether a solution can actually be truly deployable or not. And that's where this modeling and simulation based approach comes into picture. Now we'll talk about why we are going with why the existing solutions tackle more on cumulative and we are looking at instantaneous, and what has actually helped us reach that goal. But just to give a bit of a glance of how the existing noise levels compare. Uh, Today, using the tool again, today we saw that the total noise level at a frequency range of 50 hertz is clearly around 120 to 130 decibel that we are getting. Now, 130 decibel is a huge amount of noise. That is basically almost we are in the borderline of exceeding the safe threshold for marine species. And when we look at higher frequencies, 100 hertz and 200 hertz, this noise level increases more and more. Uh, but the point I'm trying to make is that this is the correct point. This is the right time that we need to be able to understand, and we need to be able to perform actions, take policies as we grow into the future. Now, this is not an immediate problem. This has been happening for decades. G.V. Frisk, around 10 years ago, in his paper, has established that at every decade there is a 3 decibel increase in the noise level. But the pattern that we are seeing is much more than that. And there is a significant reason for it, because as we grow, with the rising years, the kind of shipping, the kind of technology that we're using is increasing. The size of the container has doubled up. The kind of weight that a container can take up has doubled up. The propeller cavitation noise that is being generated is much more today as compared to what it was earlier. So there are a lot of factors that contribute towards this increase in the shipping traffic, and no one single model, like no mathematical model that we establish. So similar to any mathematical model that was established during the Cold War period, that has been the base during the Cold War. An acoustician named Donald Ross is the one who created. He basically grabbed the noise recordings from sushus, and he then created a mathematical model that allows us to identify the shipping noise or noise level from a single emerged from a single ship using its properties, length of the ship, speed of the ship, and so on. However, with an exponential rise in the shipping traffic and the shipping noise, mathematical models do not cut existing mathematical or equational models do not cut out for noise estimation. And that is where we have integrated a lot of artificial intelligence into our tool, and I'll talk a bit more about that. Now that we understand the problem, what is the motivation? Like, okay, fine, we'll solve the problem. What are we really trying to achieve here? Now, first and foremost, fuel and route optimization. Now, an increase in the shipping noise, so being able to monitor what is the noise that is being generated by a ship in real time will essentially tell the shipping industries will help them identify which are the vessels that needs more maintenance, because an increased noise, which essentially means that there is a huge amount of drag and the engine is inefficient, and all of those factors basically increase operational cost. So identifying well before time uh, uh, what are the vessels that needs any kind of maintenance is an extremely important aspect. Environmental impact assessment is again an important factor. Like most of the projects that we do, especially in the maritime domain, that involves establishing of shipping lane, establishing of ports. In fact, my able colleague Catherine also recently did a research work where she analyzed the fact that most of the port construction, while we are considering the impact that is being generated, with the noise impact that is being generated, we are not considering the wider impact in terms of the marine organisms in the place. What kind of habitat are we destroying? It's essentially just in terms of what kind of noise level will reach the shore, not in terms of how the habitat is getting destructed and so on. Any kind of naval equipment, any kind of submarine, let it be operation of sonar, submarine stealth planning, everything requires us to have a approximately good enough signal to noise ratio mapping, which tells us what kind of noise level is in the region. Because the more the noise level, the more difficult it is for the sonars to operate. The efficiency of those equipments will reduce further and further. IMO is tightening its regulations. Now IMO has released a glow noise project that we are also participating in. But this will basically put us on map, allowing us to propagate further and abide by those rules and those tightening regulations that we have. And in terms of the monetary aspect, now we have seen that sustainability has been a topic of talks for a lot of time now. It's been almost around a decade that people are talking about how can things be more sustainable, and industries are pouring more and more money to reduce their carbon footprint and so on. So having a tool that basically lets a port analyze what kind of noise is coming towards their port, what kind of each ship that is coming to their port, what kind of noise are they generating, will essentially allow them to optimize the docking and prevent any kind of noise hotspots that is being generated near the region. So basically promoting more of an eco-conscious business. And of course, protecting marine habitat is something that is always there. That is the primary aspect. But I also wanted to bring out the other factors into picture. Now, when I said about the ports being able to identify the kind of shipping traffic in the region and so on, so this is a glimpse of the tool here again, where you can see that as a user can hover over a particular vessel, it basically shows us the noise being generated by that particular vessel, the vessel details, what is the name, MMSI, the speed at which the vessels are moving, and so on. And of course, the color-coded ship details. So this is not ambient noise map. This is just the noise that is generated from the ship's propeller, which basically showcase the color codes basically showcase that the darker vessels are having higher noise levels, and the lighter vessels are having the lower noise levels. Now this architecture that Sir showed a glimpse of, I'll expand a bit on that. Now it's not easy for any kind of a tool generation when we talk about ship noise map, real-time estimation of shipping noise, and there is a reason why it has been a difficult venture for many people, in the past. The reason for that essentially is that so estimation of shipping noise requires a lot of information. It requires the data about so we collect the data about the bathymetry, the temperature, salinity, sediment, all about the ocean properties that are required for estimation of the sound speed profile, which basically tells us how a signal is supposed to propagate in the water, how much reflections is going to happen, how much refraction is going to happen. We also consider the seabed attenuation, how much, depending upon the type of sediment, the attenuation that is generated by the seabed is different. So we consider that and we feed all of that into acoustic propagation model. Now, in terms of acoustic propagation model, again, there are various models, which basically depends upon uh, which location you belong to. Whether so, as I mentioned, the spatial, the tropical aspect of the region. Uh, for regions where we are so even though Indian Ocean region is deeper in terms of the depth, the fact that we have a high temperature in the surface, which basically means that up till at least 500 meters, 1 kilometers up till depth, the temperature never reaches a 0 degree gradient, which means that the signal, so up till that point of around 800 meters or below, uh, any kind of deployment, any kind of signal has a massive amount of attenuation that happens to that particular signal when we're talking about long range propagation. So therefore, it is important for us to identify the right kind of model. Now, I'll come back to this. This is an important bit that we have integrated into the tool. And we have not used so PRAM model is a base model that we have used, but that is not what our tool is actually using. Now, in terms of AIs, again, we basically used we created an API that talks to Spire and that essentially gathers real-time AIS data, much like what marine traffic or any other kind of tool provides. It gathers real-time AIS data, what is happening in that current spot. And then, of course, we have a lot of error detection and correction that happen in that particular data, some pre-processing. And then we use the most advanced model, which is a Vatican model for estimating the noise that is being generated from the ship. So when I say Vatican model, what's actually happening here is that, so as I mentioned earlier in the Cold War period, Donald Ross created a model using length and the speed of the ship. What we are doing now is that we have divided the sound into 3 different profiles, and depending upon the speed with which the ship is moving, if it is moving below the propeller cavitation threshold, then we consider the engine noise that is being generated by the ship. So again, we need engine parameters of the ship, the number of engines, the block coefficient, and so on. And then if it is moving at an increased pace, which is exceeding the propeller cavitation inception speed, so that essentially means that the noise that is generated by the propeller is basically overtaking the overall noise of the ship, and therefore then we calculate the noise of the propeller of the ship. So we have a model that basically differentiates between the two and identifies the noise being generated by the ship, and all of that is what is being fed into our noise map. Now, as we move forward, now the tool that we have generated, again, we always talk about to see, to understand, and to share. It is extremely important for us to have any kind of tool that is deployable in multiple devices so that it is much more usable and it is much more user friendly. Creating a tool that basically needs to be running on a user's high computation machine wouldn't really be, again, a viable solution. So we wanted a solution which allows us to run it on cloud so that as a user, you just have to select a region, you have to drag a region for which you're interested in obtaining the noise map for, and the tool will essentially provide you the noise map for the region. And all the computation, everything happens on the cloud, which basically means that the data gets stored, it gets cached so that it can be fed on multiple instances. We have a historical data that we record if you want to go back and identify or you want to perform some analysis on there. Um, and again, based upon where you are at, what device you're using, we support a plethora of devices, both the large breakpoints, computers, as well as handheld devices such as mobile and tablets. Now, no, so as I move forward towards the features, there are two key components that has basically helped us achieve the kind of performance that we are gathering for. The first feature is H3 indexing. This is a technology that is developed by Uber. So what that essentially means is that we use hexagonal spatial geospatial mapping for mapping purposes. Now, this is different from any kind of a grid-like system that we usually have because it essentially means that there is a standardized global coverage that we have. So to give an example, a hexagon having a certain unique ID is the same across any kind of place in the earth. So it doesn't matter if I map it in my tool or some other tool. If I just go to an Uber's let's say interface and see what is the ID for that particular hexagon, it is the same. So the point I'm trying to make is that that standardized approach allows us to expand. So right now this rule is centric to just the Indian Ocean region, but then we are planning to expand a bit more on that as well. So a hexagonal approach allows us to expand. Now, hexagons have an increased spatial resolution, which means that it allows for fine-grained modeling and noise distribution across the ocean. Um, because of the fact that these hexagons are pre-computed, we don't really have to go about identifying which grid the noise is coming from, and all the noise propagation and everything we are able to directly map to each of the single hexagons and therefore perform the mapping. Now, in terms of the last key feature, again, as I mentioned, we have integration with multiple vessel systems, marine traffic data elastic spire. So we have the capability of automatically ingestion of AIS data. So all these external vendors we can support. And at the same time, if for some reason we feel that the user feels that they need to upload an AIS data manually and they don't want to use an automatic AIS data for any kind of operation, let's say a naval operation mechanism a naval group wants to upload their own AIS data, we have the feasibility for that as well. Now, let me help you. Let me try to backtrack a bit in terms of coming back to the whole ship noise generate mapping aspect. Now, not going into too much amount of details, just to quickly showcase the methodology about it, or basically tell about the methodology about it. So what we have done to estimate the noise that is generated in the region is that we have divided the whole region into small grids. Those grids are basically being formed by hexagons. And at the center of each grid is the receiver point. And from each receiver point, we basically calculate a radius of 200 kilometers. And any kind of ship that is falling within the 200-kilometer radius, we calculate the noise from the ship and how and what is the impact of the noise generated from the ship on that particular receiver point. And with the 200 kilometers, because 200 kilometers is like no noise and no signal strength in Indian Ocean region goes beyond the 200 kilometers of range. And therefore, that's the range that we have considered. So as we estimate the noise, uh, for each ship, we identify that what is the ship type, what is the propeller noise that is being generated, what is the engine noise being generated, and all of this is happening in real time. So just to give you an understanding of how much computational power goes into it. However, it is also important to understand that it's not so most of the existing solutions that we have essentially uses most of the existing solutions that we have today uses empirical models to solve these kind of problems, which is the estimation of transmission loss. So what I talked about the ship and the receiver, then when the noise propagates from the ship to the receiver, how much transmission loss is happening between them is something that is computed empirically. However, and this is work that we have done just a few years ago, we wanted to identify an approach which allows us to perform real-time estimation, which means that we cannot have a model. So with the empirical models, for if you can imagine, for every ship and receiver pair, if it's going to take 10 seconds to compute the transmission loss, you multiply that by thousands and 10,000s of ships and receiver pairs. So we are talking about something called as an order of n computational complexity, which means that as the number of ship and receiver pairs increases, so does the computational complexity. And that is what the existing PyRAM model that I showed you had. What we went ahead and did was we basically created a neural network which basically performs a real-time estimation of transmission loss. So instead of using a mathematical model, again, we constructed a neural network around it, which will predict the transmission loss for the given region. So this neural network is trained only for the Arabian Sea, Bay of Bengal, and the southern IOR, the exact area that we have used right now. And the image that you can see on the bottom right is the computational efficiency, the amount of time taken. So although this looks like a very artificially made graph, it is not so. So the time complexity, as you can see, for 1,000 sender receiver pairs with a neural network was nearly 2 seconds, as compared to with the existing PyRAM model, the mathematical model was close to 160 seconds. So that's the kind of drop in execution time that we have achieved using this neural network. And as you can see from the graph on the bottom left here, there are some, obviously there will always be room for error. So we are considering some plus minus 5% of error rate here. And as you can see, most of the spread is within that category of plus minus 5%. So plus minus 20 decibels of transmission loss that we are getting. But majority 85% of the data that we considered is falling within the acceptable range. In terms of, it's important for us to also validate our work. We had a recording from made from the off the coast of Goa, and what we had basically done was essentially we basically placed our work on top of the real recording that we have. So as you can see, our work, we are very close to the real recording. Again, a plus minus 5 decibel, plus minus 5%, 10% in values is acceptable range, and that is what we're aiming for. So we did compromise a very small 5% in accuracy, but then we gained a massive amount of advantage in terms of reducing the computational complexity of the algorithm. So moving forward, I just wanted to provide a sneak peek. Marine spatial planning that Catherine mentioned, this is what we are aiming for. This is what we are integrating it towards. In the broader picture, we want to create a tool which accumulates all kinds of different information in a single place. That basically means that right from climate change risk management to resource mapping, understanding where is snapping shrimp, where are the oil rigs in the place, if there is an oil leakage happening, where is it happening. Every map, every MSP tool that we have can showcase the AIS data or the shipping traffic in the region, but we want to go step beyond, and we want to also showcase the what is the useful information that we can derive from that particular data, because that is more valuable to the policymakers for constructive policy building. And that's where that's our aim behind creating this MSP tool, and that is why we are aiming towards the ship noise estimation and so on. So for each of the data that we have, the wind, the shipping traffic, the oil rigs, we will be extracting useful information out of it, and we'll be integrating that into the planning tool. So in terms of the future, we are essentially looking at an expansion of AI-driven monitoring system. We are looking at integrating of cloud-based UDA platforms. The sustainable policies is something that we're aiming to be adopted by the governments, and any kind of broader project, any kind of massive project requires a community-driven approach. Anything that requires that the people on ground. So we have people. We had the team go to different coastal communities in Gujarat and Maharashtra and other places, and we have interacted with those people, and we want support from such kind of coastal communities who can perform data collection, who can participate in this particular initiative. So as I end my presentation, now, of course, it is engineers definitely develop the tool, but then I feel that it is every stakeholder is extremely important for us. Every person in the team is extremely important for us. This initiative has been, from an engineering perspective, this initiative has been led by Jay, and he'll be making the demonstration next. But then every single person that you can see in the picture is extremely crucial, and they are the ones who have helped us through this initiative. This has not been a easy challenge for us. This is something that we have been working for the past 5 years or more than 5 years to begin with. But then it's very happy. We are very happy to see close to completion for this particular initiative. And with that, I stop my presentation here, and I request Jay to make the demonstration.
Yes. My name is Jay Pinsarkar, and I'm working here as a lead for this project as considering the software development part. So basically, this is how the user interface of the shipping radiated tool will look like. Basically, tool is divided into two components, usually in instantaneous noise mapping and cumulative noise mapping. So at the top right corner, you can see that you can toggle between those two components. So first, we will go ahead with the instantaneous noise mapping. So instantaneous noise mapping gives the real-time ship-rated noise mapping based on the current vessel's traffic. Uh, so in that, on the left side, you can see that there is a feature to add a AIS layer and bathymetry layer. So when we add the AIS layer, so current vessel traffic will be popping up, and if you can select the vessels, each ship vessels details will be popping up with the ship noise at the source level. Uh, Coming to the second layer, the bathymetry layer gives the ocean complete visualizations to user. So it will be helpful for user to visualize the ocean depth while selecting the area of interest that the user want to calculate the noise level for that particular region. Below that, you can see that a user can switch between the resource frequency. Coming to the functionality of the area selection, So we are giving us the two user inputs option for area selection. So user can enter directly area of interest can south lat long coordinates can be put up manually, or just user can drag and select the area that you want to calculate the shipping radiated noise. So for that area selection, we also applied the different validations. So while selecting the area, for example, like if user selected on land, so there is a restriction on selection of land. So that's the kind of validation is also applied for the area selection. And coming to the area selection calculation part, so area selection functionality gives the if for example I am selecting the region right now in the depths of the ocean. So accordingly, what is the available by considering the bathymetric data of this area, it is giving us the depth arrays of values that can be select as a receiver's depth option. So that is the available depth right now. I select the more depth in the ocean, so you can select that the say to the up to the around 3,000 meters. So if, for example, right now, if I selected near the more near the coastal region, so you can see the difference between the depth receiver depth limitation. So right now you can only select with the 50 meters of depth. So that kind of validations and calculations are applied right now. So let's select one area and plot our noise mapping. So after selecting the area, as Sridhar sir also mentioned in the presentation that the H3 indices that we are using. So for the H3 indices lying in the area that is passing through the backend for the calculation. And after clicking on generating, it will be started the calculation of each for the each receiver point. So each H3 indices will act as a one receiver point, and the 200 kilometers area within the 200 kilometers of radius, whatever the vessels are pounding out. So for each vessel, it is calculating the transmission loss. So the transmission loss considering the different factors like what is the mathematical part or what is the reflection of the sound, what is this absorption due to the sediment. So that factor it is considering. So while it is computing, we can go ahead with previously calculated results. So I'm established different case scenarios that will showcase you the tool's capability and the accuracy of the tool. So first I'm selected the region in the low dense area, vessel traffic area. So you can right now see the diverse spectrum of the noise. The area, the shift far near to this area is giving this the noise range from the 90 decibels to 101 decibels. And the shift is far from this area is giving us the noise ranging from the 10 dB to 30 decibels. In terms of the second case of mediumly dense traffic zone, so you can see that the tool is calculating right now the results is between the 90 decibels to 120 decibels. But right now you can see the accuracy of the interpolation that we have done. So not is tool not giving us the directly based on the AI's location of the ship, but it's interpolating the according to the results. The third case, I select the scenario of a very high dense area. So right now, as I mentioned, if for each receiver points is calculating, and right now for each receiver, the 200-kilometer radius, in high density area, the shifts found for each receiver is around 2,000 to 3,000 vessels, number of vessels. And for such heavy computations, also tool has the use capability of the computations. Fourth case I considered as near the coastal region with high density area. But right now you can see that there are lots of vessels, but the noise level bit I gave is in a low spectrum. So the reason for that is if ships near the coastal regions are with lesser speeds, and also there is a sediment thing also there. So sediment absorption factor will also rise in the sun. So that shows the accuracy of the tool. So it's still calculating. We can go ahead with the cumulative noise mapping thing. So cumulative noise mapping thing gives the logarithmic sum of the noise level for the particular time period, and for based on the specific time period, based on the AI traffic for the specific time period. So it's taking some time to calculate. So similarly, you can see the logarithm. Same feature as the AI layer and mathematical layer as in the cumulative noise map also. You can select between the receiver's frequency also. There is option of you can download all those your computed result in a PDF or image form, and you can reset all those layer in it, using the reset functionality. So coming to the final, this software is also available on cross-device device platform. So you can easily operate on the desktop, mobile, and tablet views also. It's taking a bit longer time to calculate. I should select a smaller result. So you can see that for each indices is going through the loop and calculating the transmission loss, considering all those factors. Yes, you can see the results right now. That the real-time thing right now we have calculated. Yes, that's all from us. Thank you.
Thank you, Jay and Sridhar. I think all of you can see that each and every code has been hand coded by the team, and Sridhar has been doing this for almost 7 to 8 years now. And in the last 3, 4 years, our team has expanded. But I would like to say that this is a single-handed effort of Sridhar right from the beginning. And as he mentioned that it keeps evolving, and there is so much more that one can keep just adding. I mean, so many more applications can be put on that. I mean, I have few of my naval seniors here. Even for deployment, we can provide a tool like this. And even we have also a version called the passive sonar deployment tool, which can be kind of used to find out what is the best detection position and what is the best position in terms of minimizing the vulnerability. So there are various applications, I mean, both from military as well as non-military. And as we said that every month, this is an innovation series. There are multiple aspects of the marine spatial planning we are trying to populate, and they have worked on various dimensions. So we'll open it up for our esteemed guests to give their comments, or if there are any questions also, we'll be very happy to answer. It's an open platform now. Anybody has any questions, please feel free to ask, and you can just switch on your mic and go ahead. We are a small group now. If there are no questions from the audience, then I would request our esteemed panelists who we have requested to join. Commodore Anil Jaisingh, sir, you may like to go first.
Thank you very much, Arnab. It's been really fascinating. I think you guys are doing some path-breaking work in the underwater domain awareness space in the country. And I'm always fascinated by the innovative sort of steps you all have been taking with your team. And my congratulations to MRC and to the complete team, including yourself. I've been seeing you grow from when you were, just starting out, and you achieved tremendous amount of success, and, you really path-breaking success in this field. And I congratulate you for that. I hope you continue this, because this is probably a pocket of excellence that is very unique in this country at the moment. I'll just have a few comments, but I'll start off from Sridhar's last sentence of his presentation, where he said that this tool is not just about measuring sound. In the current maritime environment, it's about a lot more than measuring sound. It is going to shape, it could be used effectively to shape the geopolitics of the region, if I may take it to a different level altogether. And I will talk more as a practitioner than a scientist, because as a former submariner, I understand the importance of underwater sound and how it determines everything, because that is the only way of measuring anything underwater is sound waves. You don't have the electromagnetic spectrum, you have nothing else. And the sound waves are so susceptible to the vagaries of the hydrographic domain, or the ocean domain, that there is no generalization that can be done. Sound velocity can change in the same area 4 times a day. We've done it in submarines. We measure sound velocity almost every 4 hours, just because we know there will be changes. They're dependent on temperature, salinity, pressure, and all the other things, that sedimentation, etc., and all the other things that came out in the presentation. So I think this tool is extremely effective. I just wanted to one question. How are you monitoring each and every ship in this very dense shipping environment? Are you using AIS data to sort of correlate platform noise to a particular ship, or what is the means? And once you do that, and you find that there are ships which are polluting the environment beyond acceptable or permissible limits, how do you plan to then convey this to the concerned authorities? Because it's not a, yes, I agree, shipping as a whole has to get their act together. They have been doing a lot of good work in green shipping, etc., but there's a lot more to be done. It costs money, it takes time. Shipping is a business like any other business. If it's not commercially viable, people are going to hesitate to do it. But there will have to be some sort of policy framework which ensures that this gets done. That is in a generic sort of a manner. And India, I think, more than anybody else, because our shipping fleet is actually more than 20 years old. Majority of our shipping fleet. We really need to address that problem. But how, if and when you find ships who are polluting in coastal waters, Indian coastal waters, how then are we going to single these out, and what are the kind of measures that can be taken to ensure that either they do not operate in these waters, because it's very difficult to stop a merchant ship coming in and going out. Obviously, there is no regulatory framework presently in place, either internationally or locally, to prevent a ship from coming in when it has to. And this will get more and more important, because, as you know, particularly in India's case, let me talk about India and the Indo-Pacific. The Indo-Pacific is now the center of gravity of global geopolitics and global geoeconomics. 65% of the global GDP is generated in the Indo-Pacific. Already 100,000 ships more than 100,000 ships are transiting the Indian Ocean. India has a pivotal position. It's right in the center of the Indian Ocean. A large percentage of these 100,000 ships pass close to Indian waters, whether within the Indian Ocean or transiting from the Atlantic to the Pacific and vice versa. The Malacca Strait, or we sit astride the Malacca Strait, 70,000 ships transit that narrow waterway. So it has a huge impact on the maritime domain, or the maritime biosphere, or whichever way you want to put it, marine life, marine growth, everything. So, how and what is India going to do, and how are you as a research organization going to create scale up to a level where this can be done at a national level? And what sort of regulatory framework do you recommend should be introduced to ensure that these things happen? I mean, this is all very nice to say that we can do this and we can do that, but we've seen that it's very difficult. We are going to grow into a 5 trillion economy and a 10 trillion economy and a Viksit Bharat of $30 trillion economy. The exponential increase that we will have in the amount of trade and the amount of shipping that will go to and from Indian ports. We're getting deep sea ports are coming up, Vizhinjam, Vadhavan, Nicobars. And there are lots of environmental concerns being expressed about these ports coming up. So all these factors combined will need to have a very focused policy sort of framework. Now, I'm not getting into technical aspects of it. I'm just getting into policy framework. So when you develop a tool like this, which is going to be very effective in addressing this, what have you visualized as scaling this? I'm only talking right now of shipping. I'm not talking of underwater exploration. I'm not talking of things like that, or effect of sonars on fishing and etc., on whales and things like that, which have bothered people for many years. In fact, if you remember correctly, the US Navy had gotten some regulation about where and when a ship or submarine can transmit on its active sonars, because it was disturbing the whales and the other underwater mammals in the region. So those are the sort of issues which I would like to sort of just get some more inputs or some sort of more light on it, because I'm ignorant about these things as well. Climate change events, we know that it's very important that climate change events are understood in the right dimension, and we are able to predict these with more accuracy. We know they're going to become, extreme weather events are going to become more frequent. If you remember, the tsunami in 2004 took everyone by surprise. Most of us hadn't even heard of the word tsunami before that. Now, of course, a lot of mitigation measures have come into play, but still not enough to be able to predict well in advance that there is some disturbance happening, and the sort of acoustic pattern is changing. Is it going to lead to an extreme weather event? Can we have risk reduction, risk mitigation, etc.? So that is another very important application, as has come out in this. Blue economy initiatives, I don't need to elaborate on. Fishing, of course, is a major thing. What else? I've been jotting down quickly, a lot of things which came to my mind. And of course, I think the most important two things again, which I would like to highlight, or three things, is firstly, you were very right, capacity building. We cannot do this in isolation. No country can do this in isolation. MDA or UDA or even situational awareness in an area as vast as the Indian Ocean is not possible by any one nation. So capacity building is very important. Most of the Indian Ocean region comprises the global south, who do not have the means to go in for expensive means and expensive technologies to understand this. They have to be integrated into a technology framework which they can understand, and they have the financial wherewithal to implement. Of course, with Indian support, because India is the Indo of the Indo-Pacific, as I've always maintained. So that's one part. So how are we going to highlight? How are we going to sort of bring this capacity building approach? How do we bring everybody on board and make them understand the importance of this? Second, of course, is we have to go beyond the Arabian Sea, the Bay of Bengal, and the Southern Indian Ocean, which is your present area of concentration. Third is, how are you interpreting this information and making it actionable for the policymakers or the person at sea or the regulatory sort of bodies at sea to ensure that these are implemented? That is also very important. And would this find acceptance in a larger framework of, let's say, in the multilateral frameworks, Indo-Pacific Oceans Initiative, IORA, IONS? Because these are things that these are common to all. It's public goods we are talking about. It's like a non-traditional security threat in the maritime domain, actually, if you look at it. So how are we going to take the next step to bring it into a larger policy framework on maritime security in the region, whether it's through Quad or it's through IORA or it's through, like I said, the IPOI or East Asia Summit or whatever it may be? These are the things which I think the next step which we will have to focus on is this. I think it's a great initiative. And coming back to what I said in the beginning, how do you distinguish between, let's say, you showed three areas on the map. Now, there's a lot of fishing traffic between India and Sri Lanka. Fishing boats of all shapes, sizes, from mechanized trawlers to little boats with outboard engines. We've seen them all when we've operated at sea. Then you go towards the west coast of India. There are certain concentrated pockets of shipping. There are certain not so concentrated pockets of shipping. Shipping can be very different on different days. So what is the sort of monitoring framework that you can establish? Not a generic noise measurement tool, but a more specific noise measurement tool which actually addresses the problem and is able to introduce or create a regulatory framework which addresses these issues. So I'll just end at that, and maybe in the discussion some more questions will come up. But thank you very much. It's really been a fascinating presentation. I've learned a lot from this, and I think there's tremendous amount of potential in what you're doing. So please continue. I just want to tell your team, please continue this good work you guys are doing. It takes time for people like us to understand this. It takes time for policymakers to understand this. But I'm sure once they have, sky's the limit, or the depths of the sea are the limit, or whatever way you want to put it. Thank you very much. Thanks a lot for this presentation.
Thank you, sir. Actually, I'm sorry I didn't introduce Commodore AJ Singh. Sir has been a submariner. He has commanded submarines, so he knows it very well, what it takes to deploy submarines. And he's been a senior naval commander. And most importantly, I mean, you can make out from the points he has made, he was India's naval attaché at London. So he understands geopolitics very well. So thank you so much for a very, very insightful comments that you made. And first, I will request Sridhar to answer a few questions, and then I'll on a larger. You have raised multiple points, so Sridhar, I would please request you to first answer a few of the technical points sir has made.
You're right, sir. Thank you. And again, Anil sir, again, thank you for those questions. What you mentioned is extremely right. So I'll try to answer some of the questions to the best of my capacity. To begin with, I'll humbly accept I'm not a geopolitical expert or a policy expert, so take it with a pinch of salt. That being said, coming to the first question that you mentioned, how we perform this computation, again, as I mentioned, it's basically the AI that has helped us reach this kind of a computational power. Before AI, as I mentioned, the computational requirement that is required to perform so much amount of basically identifying the ships. So again, like I won't go too much into depth. We have done a lot of pre-processing on the data. So whenever a data comes, we identify which ships are near to what point, and we basically we apply something called as an indexing for faster processing. So there are a lot of computational methods that we have applied, and that is what has created this project to be so complex, but at the same time also rewarding in that sense. So yes, but to cut it short, it has been definitely a lot of processing, pre-processing that we have done on the data, and the use of AI, specifically the neural network, that has allowed us to create such kind of a project. So a large part of the contribution definitely goes to the advent of AI and how the whole thing is moving towards communities moving towards applications of artificial intelligence. In terms of outreach, now I'll try to answer these questions from my perspective in terms of outreach. The first thing I would like to mention is that one, in terms of how to make people more aware. So before we actually go about solving a problem, I think, and I might be wrong, but currently in India we have a problem of actually we don't even know what the problem is to begin with. Like no one, like this is not a very widely accepted understanding of what. No one really knows that what noise level is in the region. No one understands. There are a lot of forums where people talk about it, but there's no pictorial representation that showcases such kind of data in real time, because unless we showcase that kind of information, so again this comes back to that, to see, to understand, to share, a framework that we are devising, in the sense that sharing needs to be done in such a manner that people understand the importance of the situation, or like the color coded maps. Like if a simple example, the color coded maps, we specifically used those kind of colors ranging from blue to green to red, because then the user can visualize that what kind of criticality we are at currently. So yes, so in terms of making it more reachable, so this tool is more in terms of making people aware of the problem, making people identify that this kind of a problem exists. In terms of outreach, I can see that like many India is currently, as you might be rightly aware of, IMO is currently pursuing the Glow Noise project, and India is being part of that project, and MRC is also part of the team from India, which is representing India in this Glow Noise project, the wider initiative. And that is a very able forum for us. We have already displayed some aspects of this capability. There are tools there, but that is an able forum to make it more reachable to the wider audience. The second aspect is the coastal community. Our engineers, Shreya and Ayush, are here. They've been to coastal community. They've been to the coastal community of Gujarat and Maharashtra and other places, as I mentioned, and they've interacted with these coastal people, fishermen per se, and they have rightly pointed out that like they understand that there is fluctuation in happening in the fishing. They understand that seasonal fluctuations are happening in the fishing. They understand that, and in some places they are able to find fishes, in other places they don't. But then there's nothing that tells them in real time that this is the reason why this is happening. An increased noise level will disperse the marine habitat in the region, and this kind of information is not, this real time information is not there in their hands, and that is the reason why again we made this in a very phone handheld device, so that because most of the coastal community, or the broader community for that matter, will not be sitting in a machine, sitting in a computer and looking at the data. They want something that is handheld, something that is accessible at an ease of time. And that is again an idea behind this, that we reach out to the common people, because unless and until the communities themselves raise a voice and say that this is causing a disturbance for us, policies, I might be wrong, but policies might not be something that would come up until this has been actually identified as an issue to begin with. So yes, I think those are the two major factors that I feel that are in terms of outreach. And of course, most of the port authorities. So when we went to Goa as part of a UDA summer school, we saw that the people who sit in the lighthouse, they basically look at a screen which showcases the AIS, which basically showcases what is the incoming traffic of vessels in the region. But imagine if they also have this information of what kind of noise level is being generated in that region.
Correct.
That is a huge power for them, because then that they can see visually that, oh, there's a container vessel that is moving at this kind of a speed and that's bringing a lot of noise into our shores. So again, it's more in terms of making people aware, but I believe that that is what will drive people into more like creating policies to solve the problem. So yeah,
Can I
those are
can I
my
just
two.
interject for a minute, because and it's my ignorance which is talking now.
Yes, sir. Please,
Uh,
sir.
is there a possibility, and this is just I'm thinking aloud, of at some point in time, when this is more accepted worldwide and things like that, of having sensors on undersea cables, let's say, which are continuously monitoring the movement of shipping and et cetera, and being able to give this information. May not
Uh,
be in the next couple of years, but long term, something like that can be thought of.
if sensors become cheaper, so then sure. I
Yeah, of
think
course. It's all a matter of resources and money. At the end of the day, that's what counts. No doubt about it. Yeah.
Yes, sir. Yes, sir. However, at that being mentioned, the primary focus for this tool has been the economic viability of it. The fact that you need to be able to see the data without that much amount of cost and infrastructure being put in. And that has been the primary approach, primary goal towards this. That is the reason why we are relying on satellite data, which provides a similar kind of information. Of
Right.
course, not with 100% accuracy, but again, it comes between that cost versus accuracy trade-off that we do here. And like from the analysis that we have done, as I said, a plus minus 5-10% is the gap that we are seeing. Like as I showcased in our graph, the recording that Arnab sir did in Goa region versus what we have developed now. There's not much of a difference in terms of like there's a certain trade-off, but that is an acceptable trade-off, and we feel that
Okay.
that is what we are moving towards, more of an economically viable approach. And if you look at it from a policy perspective, I believe that this is enough in terms of the policy part, at least to begin with. Of course, I agree with you in the aspect that we need to make a lot of improvisations.
No, that's right. You're at the very, you're the research people. The scalability production will be done by someone else, obviously. But
Right.
thank you. It's been a fascinating. For me, it's been a fascinating presentation. Thank you so much.
Sir, I just wanted to add a couple of points. You made a few policy aspects. Sir, in terms of policy, I mean, typically, global policy, regional policy, national policy, and even local policy. And you also know that there is phenomenal gap in all of them and, understanding and everything. So, firstly, as far as the innovation is concerned, 2019, in a very primitive form, we won a global innovation challenge, and I had visited. We were invited to France, Brest, and this was showcased. And that's when the European Union people, I mean, the Maritime head was there, and they said, "Have you gone to IMO?" So I had no clue, to be honest, that this could go to IMO. And they said, "We can take you to IMO." I mean, I also didn't know that individually you cannot go. It's a nation which is a member of IMO. So once I came back, I was lucky that, in a couple of months, I was in front of the shipping minister with the entire senior, the DG shipping to JS shipping and everybody. But believe me, sir, it took me 1.5 years from that point to actually my paper to go to IMO from India. So MEPC 76 in 2021, our paper went to IMO. And based on our paper, now India has been nominated as a lead country for underwater noise in the Indian Ocean. IMO is taking it up very seriously. And what they appreciated was that we actually talk about the tropical waters. I mean, my argument was that the tropical conditions to be factored, I mean, we as a developing nation can never meet the European standards. So we will have to work on our own standard, and that was the main point. So now, last year they have formed a national task force, and we are part of that task force. And IMO has, so we made a presentation to the IMO coordinator, and DG Shipping has been extremely kind. Earlier, Mr. Amitabh Kumar, and now Shyam Jagannathan sir, they have been, very closely associated and monitoring our work. This is also a major part of the green shipping initiative.
Exactly.
So all that, so we are in discussion, but you will also agree with me that in the government, things do take its own time, and that's one. So this is one aspect, but also one point which has to be highlighted, or you have also mentioned, is awareness of the policymaker, the importance of what we are talking. I mean, what Sridhar said. So what we have done is the Government of India has a platform called the Capacity Building Commission. I mean, in 2019, the Honorable Prime Minister set up this, and so they have taken 10 e-learning modules from us, and we are told that we are the top-rated domain-specific e-learning modules on that platform. So a lot of scientific community and a lot of people have gone through it, but this is part of the larger capacity building that we talk about.
Okay.
So in terms of global policy, UN has taken cognizance of this. There is discussion happening, and I'm hoping that this will probably see the light of the day. In terms of regional policy, sir, you are right. Quad and more than Quad, IORA and various other things. Now we have the chairmanship of IORA. So we are definitely reaching out and talking about things. But it will take a little while, I think, to make it happen. But what we have done, MRC pushes the policy, but NirDhwani has been focused. We don't wait for somebody to fund us, or we don't wait for somebody to support us. I mean, Sridhar has been working on this, and the important factor is that everything is hand-coded. So while you as an operator or you as a submarine commander, if you tell me, Arnab, I don't like this, I want this, my team I can tell you on the go, they can change it to your requirement. And you can see that there are customized displays. Whether as a commander on the submarine, you have a specific requirement, but somebody at the war room will have a different requirement. And even like when you are as a submarine, when you dive, you will not have access to AIS data. So our team has also worked on certain predictive algorithm that using AI based on the data that we have, we can, it will not be a complete zero kind of a situation. You will get something, and there may be obviously differences. So we can customize it to any requirement. And identifying ships. So there are so many applications. I mean, we sit here.
That's true.
When Sridhar mentioned about lighthouse, he may require something else, but and everything can be customized, and kind of we can take it forward. So I think we'll stop here. Otherwise, we can discuss. Thank you, sir.
Thank you, Arnab. Thank you very much.
So we'll request. Yeah, there is a hand going up. Rupak sir, I think you can come next, sir.
Yeah, good afternoon, everyone. Okay, I'll just take 2 minutes. I'm from Indigenous Technologies, Commander Berry, and we are working on some IDEX project with the Indian Navy on underwater noise cancellation. So in the last 2 years, I've been interacting a lot with the naval agencies on this issue, and of course, we are trying to improve performance of hull-mounted sonars. But but we have been dealing with noise, noise. I just had 1 or 2 questions. One is that the the sensors for collecting the noise, na. So you have, exclusive sensors for collecting the noise. I believe the Indian Navy, generally does, the noise. They for the Indian Navy ships, they go to the underwater ranges and, there they collect the noise signature. The other thing is about the engine noise. Na, that I mean, the submarines have that. Not all of them, but many of them now have got that submarine noise monitoring system, which gives the specific, the noise level at different points. So, but that is, like for merchant ships and all, do they have any tools to monitor the engine noise and then communicate the data? And the other thing which I wanted to share is that when we were, doing our work, so we needed some data, about the, different, the noise produced by the ship's machinery. So we went to the US Navy postgraduate school site, and we found a lot of data was available. They have declassified the data of the Second World War, which was recorded by the ships and submarines, and they have put up that data. It is available to everyone. So actually, we were even the Indian Navy was not able to give us the kind of data that we got from the US Navy postgraduate school site. So whereas Indian Navy was giving us data from simulators, the US Navy postgraduate school site provided real-time, situations, operational scenarios of the underwater, data they had collected, which was very helpful in, analyzing realistic data actually. So I got in touch with few of my friends and all, that can we also, can we have a philosophy of, making the data available, because without that it is difficult to do R&D. You need a data in open source. You may of course at times buy some exclusive data, but generally, I think, and the other thing is in the Navy that Indian Navy itself doesn't have a nodal agency for underwater issues. So since it's very important for the Indian Navy, like we have scattered in DSR, we deal with DSR, DWE and VESI and, NSTL, NPUL. I mean, there are so many things happening, but we don't, there is no central agency to monitor, like supposing, let's say there is a difference of opinion between, let's say, Bell and NSTL or NPUL. So is there an apex body on underwater issues who will resolve, that the matter will go to them and they will give decisions, that how to go ahead. So these are my concerns, which I came across in the last 2 years and I thought of sharing. Thank you.
Just to add to what Rupak is saying, Rupak, hi, how are you? I didn't realize that
Yeah,
it was
always,
you guarding
always.
there. I didn't realize that.
Yes, sir.
All ships that go to sea and submarines that go to sea are constantly recording the HEs of merchant ships, warships, etc., etc. That's a constant process. And then we all send it to wherever they go for analysis. Now, obviously, warship information will be classified and whatever we picked up. But merchant ship classification need not be classified. It's a merchant ship. It's got a propeller. It's doing 160 RPM. It's doing 18 knots. You can guess it's a 50,000 ton ship or whatever it might be. That's not classified. That's sheer operator's understanding of how a propeller churns in the water. From that, is there any mechanism you've devised or have you spoken to the Navy to say that at least that unclassified bit can be shared with you so that this actual data and not simulated data can actually be fed into your tools to see the effectiveness of being just able to distinguish signal noise ratios, etc. Is that a next step and you will perhaps do it at a later date, or do you have anything like this?
So
Because this is actual authentic raw data recorded on a sonar.
So actually, to share with you, sir, that people don't have much of time for R&D activities. Everybody is in a hurry to put down the phone when you talk to them. It's so difficult to find people. So only personal, relations really work. And but the personal relations sometimes encroach on the official, this thing, making it slightly, unpleasant. Actually, I mean, I would just reserve my comments. So I think, sir, we need to be more informal about informal about talking to each other, and it's with enthusiasm which we need to exchange information quickly, and everything.
I'll answer your point, sir. Sir, Berry sir, you have raised some very important points, and I want to just give you a background because I was working for the nuclear submarine classifier when I was doing my PhD from 2002 to 2007, and again, data is an issue, and even that time I was a serving naval officer, but I was posted in IIT Delhi, so we were not given the data that we desired. So the only option was to generate the data and then perceptually get it validated. So we generated a synthetic data. So that's my background of understanding. And today there are certain algorithms using which, and that's what my team is also doing that. And so we have generated synthetic. And so other point is, Ajay Singh sir, you'll also realize that if you have to cover the entire Indian Ocean, how many sensors can you put and how much data can you collect? And
Yeah,
we
of
will
course.
never be able to get you so the only approach, as I had also talked about in my presentation, is the modeling and simulation. And the data needs to be used to validate the model rather than, I mean, the shallow water acoustic measurement. Otherwise, you can never get the larger picture. So there are techniques today which we are using. But what you said about the US Navy, so that data, but that is not relevant to us. Every ship has a very unique signature. So when you are working on a very specific classification thing, you have to have. So for me, it took me a year to generate the synthetic data. And that time you can imagine 2004-5, what kind of computational capability we had. So it took me a lot of effort. Then we also went to NOTPAC and ASW School to validate the perceptually what the sound we have generated, and we found almost 90-95% a match. Then the second stage was the actual field validation. We went to underwater ranges Goa and validated that. I mean, obviously Navy will always be concerned about the data security. So what we said that these computers, we'll put it here, we will never take this computer out even after the project. They remain with you, and we went there, validated the thing, came back with just the understanding of where our algorithms have kind of deviated, and then go back and fine tune them on the ground. And from almost 70% classification to we reached about 92% classification. So using the underwater ranges data. So that's a very important organization. I mean, Navy has, and other thing that you said, Commodore Ajay Singh sir, you said about the data that ships and submarines collect, it goes to NOTPAC, and NOTPAC is supposed to have the data. I don't want to comment where the data goes or what is the thing, because I'm no more in the Navy. So, but there is a system in place. How effective the system is, I think we'll have to discuss with the Navy. So I think I will stop at that. So I think if there are no questions, we'll go to the concluding remarks. Ambassador Mudgal sir, over to you, sir.
Thank you so much, Arnav. As always, a very fascinating presentations. Every time I listen to these presentations, I told you earlier also, in fact, my mind gets further loaded with the question how to finally utilize this information in achieving the goal. In fact, I heard the questions. I have been working on this. My interest in this started with my exposure to blue economy as part of the first task force on blue economy under FICCI, and then as part of steering committee on blue economy in the Prime Minister's Economic Advisory Council. I have been dealing with this now for almost 12, 13 years, but still, for me, it's very difficult to explain to my interlocutors what exactly needs to be done if we really mean blue, right? Everybody understands economy, but very few people understand why it's called blue. Yes. So today we discussed about acoustics kind of as a kind of a tool to understand the underwater domain awareness, but as part of the larger marine spatial plan, because this will form part of the large goal of marine spatial planning. We are looking at very, very extensive data sets. And I fully agree, whether the policymakers fully understand and appreciate this, not so far. It's a long journey, but why we have started this? Because as I said, today we talk about only acoustics, but we are worried, not only we in India, but everywhere in the world over, we are worried that without the ocean health and sustainability, our future could be very uncertain. Yes, because in fact, the UNSC considers global warming as an existential threat. And without the ocean health, I simply have no hope of managing climatic stability. Now, ocean health, when I mention this data, we don't really understand what's there in the relationship of ocean behavior, climate change. The whole process happens underwater. We only see the consequences over water, but it happens underwater. Be it the physical, reactions, be it the chemical reactions, be it the biological reactions, then the consequences in terms of impact on the standard circulations underwater, which then play an important role in climate stabilization. Now, this is a very, very massive task. Why we have started doing it, in spite of the fact that very few people appreciate and understand this, because we may do it or we may not do it, the world is doing it. You see, I am aware how industrialized countries have worked on aspects now for many years. And I have absolutely no doubt when they have sufficient data and sufficient analysis, all these things will then breed into full regulation, which will come in the way of developing countries. Now, India, we say, we are a leader of global south. We, like Arnab mentioned, this is a very, very expensive and technically heavy kind of approach. Now, developing countries have their own limitations, both in terms of investable money and the availability of technology. But fortunately, India is sitting somewhere in between, right? We are not we may not be so advanced as the industrialized countries, but we are not exactly comparable to the last in the queue. So we have those capabilities in niche areas. Our approach is that we sensitize the policymakers that better we prepare for this, more say we have when it comes to the international regulation. Now, this international regulation may relate to shipping. This international regulation may relate to the biodiversity. It may relate to many other factors. But at the end of the day, they impact economic activity. We have seen that. This is not the first time. We have seen that as part of the WTO negotiations, because we were not adequately prepared in the price for that regulation, because we were not part of the teams which were defining or designing the regulation. Now here, we seem to have some head start. If, as MRC is doing, I really appreciate MRC for this, because nobody else is doing it. Now, if we are able to kind of gather this data, analyze this data, and convert that into a demonstrable model and its application, I'm sure then the policymakers will understand that this could be done. Which means we don't have to fully depend on others for technology and the methodology. So that is the whole purpose. In fact, in the MRC booklet on which we are working, is going to spell out all the parameters of underwater domain awareness, not only acoustics, but as I say, acoustics, the biochemistry, the physiological features, and all that stuff. And when we combine this data, basically, as part of the MSP, we need to know how to avoid or mitigate intra-sectoral conflicts under the blue economy, number one, and then the conflict between the human activity and the ocean health. Now, unless these two things are handled, we would not know when we cross the red line in terms of ocean health. And once we cross the red line in terms of ocean health, I strongly believe that it is not a reversible process then. We all will have to pay very heavy price, right? And therefore, my hunch is that before we get close to the red lines, the international organizations will bring in very tough regulations sooner or later. And we will again land up paying the price of that regulation. One is this, that are we prepared to sit on the table, right? Or we stay out. As people say, if you're not on the table, you will be on the menu then. Yes? So I'm sure we do not want to be on the menu, we want to be on the table. Now, why would you be on the table if you do not have the basic competence in terms of understanding the underwater domain awareness? So what they are doing, it may appear, and right now, it may appear too technical, and as a result, beyond the understanding of ordinary people. But I'm sure sooner or later, we would understand that this is important. Working on what is called the way forward in terms of model policies, in terms of ending these conflicts. And once we, like for example, when we went to IMO, they understood the whole thing. Yes. And I'm sure when they see the competence, what you are doing, they naturally will call you in, because they also do not want to give the impression that, the global south will be excluded from the negotiations. And so there is international treaties, like say BBNJ. Now BBNJ will put very, very strict regulations in terms of IC operations. Now, if we don't have the basic understanding of the underwater domain awareness, then we are defenseless. We will be told that you are doing this and therefore you should pay this price, and we'll have no option. This is what, when I look at this from this viewpoint, that we are building the blocks for understanding the process so that we are not finally at the receiving end of the regulation. Yes. One is its application so that we protect our interest in the high seas. The other is that we must be there when the international regulations come into force. We should have a voice there. And that's why a voice will depend on what kind of competence we have in terms of technology and in terms of data analysis and the solution. If we can't provide a solution, they will say, get out, right? So that is what my perception of the whole. And I'm very happy that at least somebody is doing it. Whenever I go for such conferences, I highlight the importance of comprehensive underwater domain awareness in the interest of designing at least the preliminary MSP processes. Because then we can tell the world, we know it, we have the capacity. And then we can also tell the global south, look, we are standing in between. We can hold hands on both sides. On one hand, we can hold hand with the advanced countries. On the other, we can hold hand with the developing countries. So I was not surprised, for example, why underwater domain awareness was included when Prime Minister met President Trump in the joint statement. You see, there is a reference to joint research and co-production for underwater domain awareness technology, because this is going to be the key. There is no way you can mitigate climate change without understanding the underwater domain awareness in its comprehensive form. So with this, I will stop, unless there is a question from any of those who are in attendance. That is what I want to say, Arnab.
Thank you so much, sir. I'm sorry I again failed to introduce Ambassador Mudgal, sir. Sir was, I mean, this is 10 years of a decade of Sagar Vision declaration by the Honorable Prime Minister. And Sir was in the thick of it. He was India's ambassador to Mauritius when Prime Minister went and announced the Sagar Vision. So he was also part of the team which formulated the whole Sagar Vision. So he has an in-depth understanding of this. And Sir mentioned that he was also part of the Prime Minister's committee, economic committee. He was representing the blue economy aspect. And for us at MRC, Sir has been a mentor for a long time. And very importantly, Sir is leading our effort on coming out with the MSP handbook. Catherine, Shlok, and of course, Sridhar and the team is also involved. But Sir has been extremely kind, and we definitely feel that this will be in the series of handbooks on MSP that has come up, and we want to assure, and Sir has also mentioned that this is the other handbooks that have come on MSP are largely talking at a very high level, and the work that we are trying to do is going to connect that high level to the ground. So that comment, sir, we take it very seriously, and we are going to work very hard to make it happen. And I mean, this is, as you said, sir, it's a journey. And I want to assure Commodore A.J. Singh, sir, that, sir, we have 6 researchers working very seriously. And these are all coming from very, very top, I mean, IIT Bombay and IIT Delhi. They've been with us for almost 3-4 years now. And one is working on climate change. Slok is working on coastal management. So the digital tools for shrimp farming and various fish finding, all that is being led by him. Then we have Romit, who's now IIT Delhi BTech, and now he's doing his PhD working on sediment management. So that's a very important area. And navigability is such a big issue, but there are so many other aspects which are important. So again, there will be an MSP there also. Because representing it in the digital form is so much more important. Then Catherine is herself driving the blue economy. And then we have Pradnya working on acoustic fingerprinting, sir. So that's also something we are looking at. So I think I'll give a moment to Sridhar, and we have Shishir Sirotra, so Commodore Shishir Sirotra, sir, from RIS. Sridhar, quick comments from you, and then we go to Commodore Shishir Sirotra.
Right, sir. I just wanted to again thank everyone for your amazing comments on this, and I wanted to appreciate the efforts of the engineering team specifically, who has done work on this, starting from Jay, Shreya, Ayush, Shubham, and Angela. Usually it takes around 30 engineers to work on this, but these people have put their heart and soul into it to start this initiative and worked continuously and tirelessly. So just wanted to appreciate their effort into this and acknowledge the same. Thank you.
Thank you, Sridhar. Shirotra, sir, over to you, sir.
Much for such a wonderful session. I hope you're able to hear me. Yeah. So I just wanted to, make a point that marine special planning MSP is a very important aspect of, growth of our country, and use cases are the key to be developed in this, field. You are already doing some tools. So I would like to highlight the power of, diverse applications in this area, and particularly, in the areas of port planning, inland waterways, blue economy, renewable energy, sedimentation profiling, and so on and so forth. So, you have to develop these use cases and application of this technology in these areas specifically, where it can help us, for instance, for port planning, huge scope is there. We have more than 200 non-major ports in India, as you are aware, and out of that, 65 of these non-major ports already handle cargo, and already we are in the process of expanding these ports, and MSP can be a very handy tool in identifying suitable locations of expansion, considering factors like water depth, navigational channels, proximity to transportation networks, and environmental sensitivities, etc., etc. Also, the use of MSP tools or MSP to resolve conflicts, normally which it will allow the different uses of the same infrastructure, just as for fishing, recreation, conservation, and shipping, etc. So MSP is a very important tool. Now coming on to inland waterways, again use cases are very important, and you have to, this handbook enough, or developing this handbook is good, but you have to diversify and mention these use cases in a very comprehensive manner. So for inland waterways, it's a very important growth sector for us, and navigation planning to optimize navigation routes. Also, with respect to inland waterway management of transportation, and also with respect to uh, flood mitigation, drought management, sedimentation profiling, and so on and so forth. Fisheries, I will not speak. A lot has been spoken, and sustainable development of marine resources, promotion of innovation, and in this area of fisheries is very important. Renewable energy, another very untapped resource, both for offshore wind and wave energy, and there again, grid connection planning, developing these microgrids, again a huge impact can be made by MSP. So again, you'll have to make these tools and use cases which will allow for the integration of the renewable energy into the infrastructure, existing infrastructure, whether it's for port or for inland waterways or for other related maritime clusters which are there. Fourth, most important is, you highlighted, and some of your researchers also mentioned about this sedimentation profiling, and it's a very important tool for not only coastal erosion management, but also for planning the dredging operations, and also for preventing and predicting the sedimentation in the channels. So, what I would request is that you, along with, we can give you a little bit of support. You can develop not only these models, you've already developed some models. You can highlight the aspects of data acquisition, where you are talking about gathering the data from hydrographic sources, or river discharge management measurements, and coastal erosion rate measurement, and other meteorological related data, and then integration of this data and analysis with a kind of a spatial data overlay, which can help us not only uh, uh, take decision making or do decision making, but also help us in navigation safety, help us in dredging requirements, help us in preserving the water quality, and above all, the scenario planning. All these use cases would be very important for your analysis and documentation in not only in this handbook which you are mentioning, but also for bringing the coastal economy, or the blue economy, realize its true potential. So technology is inseparable from technology. Without a socio-economic impact is no technology. Developing technology which does not have a socio-economic impact is just for research, basic research, and so on and so forth. So we have to graduate from this aspect of basic research, and get into application areas where you identify these use cases and get on, and with the impact assessment in the socioeconomic realms and domains. So that's my request to you, and we are there to help you realize this potential. Thank you so much.
Thank you so much, sir. I really appreciate your comments, and just wanted to highlight things. So today there was not enough time, so we could not go. So, and as we announced in the beginning, it's a series of monthly innovation meet. So in our second, we are covering coastal management. In the third, we are going to talk about the sediment management. And we would like to impress that we have conducted field experiments in Khadakwasla, and we have also generated data and done the impact assessment. And the second aspect is that we have now started working on the data fusion because acoustic data is hard to get, but satellite data is far more easier, and how to use models to build using satellite data to build the underwater picture. So we have, I mean, last 2 years, we have also added that part, data fusion, so that the satellite data can be used to build an underwater picture. So I think we have multiple case studies to present. Time permitting, we will, and this is a series which will carry forward. And there's a lot of documentation that we have done. I mean, now our two researchers are working on gap analysis and white paper. So the gap analysis covers a specific area, a specific application, and a specific stakeholder, and covers the real world data. Like suppose we take the Konkan coast, we talk about the sediment, coastal erosion, and with very specific inputs covered under people, economy, nature, how it impacts people. I mean, AJ sir had talked about climate change impact, but we bring it out in a very systematic manner. What are the economic impact and what are the sustainability impact? And then in the white paper, we come out with what are the policy gaps, technology gaps, and capacity building gaps. So it is very comprehensive, and by the end of the year, we will have a compendium of 12 such things which are very specific, which will support real decision making in terms of kind of solving problems. So I think we'll end there. And if Mudgal sir or AJ sir has any final comments before we close. No, I think yes, sir.
I'll just take 30 seconds from what Dr. Shrotriya highlighted about these issues. I think the most important is that most of these are aligned with our Sagarmala program, port-led development, whether it was developing a non-major ports, new ports, navigable channels, inland waterways, where sedimentation, depths, etc., very important, how the currents flow, how the river flows, etc. So I'm just thinking aloud. Isn't there a possibility that MRC with this pioneering work gets incorporated into the Sagarmala program from a point of view of highlighting some of these areas? Because that will give you not only, firstly, it will give you specific areas to work on which are of interest, and secondly, I think it will give you some sort of government financial support, because it will be part of a institutionalized program which is well funded. We all know Sagarmala is a well funded program. It's a program which is moving on track. It's moving towards a very distinct sort of goal at the end of it, of making India maritime power by 2035, whatever timeline is given in that. So is that a possibility? I don't know. I'm just thinking aloud, rather than, saying first you do something, then we'll look at incorporating you. Rather say that, look, we're incorporating you, now you deliver the results on the following areas where you've been doing research, that sort of thing.
Absolutely, sir. That's a good possibility. That's why I requested him to focus on the use cases and how these use cases can make a economic impact. Economic is very, very important. We always think that disaster management, preparedness, and having resilience, and preserving and conservation, etc., are important. They are important, but they go hand in hand with economic development. And our main aim of our Sagarmala or any such program, Ambassador Sir would also agree, that is to develop these aspects of blue economy, which is untapped potential. India is a maritime superpower, not only because of its geographical position and the size of the coastline and the economic zone, EEZ, etc., but we are a maritime superpower because of the population which also lives there. And in the past, this population has been in the prime focus for shipbuilding. We were in the ancient past, we were a maritime superpower in the times of Mauryas, Cholas, built ships. They operated these channels, and we had a vast, very fully developed maritime economy. So with the advent of technology, now we have to regain that supremacy, and economic aspect of use of technology is very key to this initiative, and we do it in a very frugal way. So as Ambassador Sir was mentioning, we can be a path breaking or a leader in the global south to carry these technologies to the global south also, and just like Incois does these advisories, so we can create a digital ocean, and this digital ocean can be shared resource for the global south, for the Indian Ocean countries who rely on us. And Prime Minister's initiative of Sagar is very important. It does not only talk about security and collaboration at that end. It talks about growth for all. So growth only comes with economic growth, and there I would like NirDhwani and Dr. Arnab Das team to focus and develop these use cases. Sagarmala, we are, and IWI and the other divisions of Ministry of Ports, Shipping and Waterways, they're always there to promote these technologies, and we can give them pilot implementations. We can find other resources, not only the government resources, but we can find other resources like the Reliance Foundation, the Swaminathan Foundation, who work in these areas of coastal community development. We can also find other means of finance for them, but the idea is to create these use cases. That's my request. Thank you.
Thank you, sir. I just want to quickly, before I request Mudgal sir to give the final remarks, Dr. Shirota sir, Commodore Sashi Shirota sir is the head of Center for Maritime Economy and Connectivity. This is a very unique initiative under RIS, which is a think tank of the MEA, but this center is also working for the Ministry of Shipping. So it's a very unique center which is there, and you can definitely make out from his deliberations, what he represents. Thank you so much, sir. And now, Anup sir, over to you.
Many speakers mentioned about Sagar. When we were kind of thinking on those lines, it was a massive kind of a burden on our shoulders how to balance economy, security, and sustainability. Now, security on the high seas is better understood because dealing with it for many years now. Yes. Economy, we better understand because we have been dealing with those aspects for many years. Ever since the human civilization, we have been harnessing for economic benefits. It is the sustainability aspect, which is a new boy on the block, as we call it, and is much more complicated, both compared to economy or the security. Because I fully understand that if there is no economic benefit, then we won't be able to mainstream this work. People won't support it. I totally agree with that. But when we look at the ocean health, if it deteriorates, has the capacity of disrupting everything. In fact, it will disrupt the economy, it will disrupt the security, it will disrupt the regulation. In fact, it will disrupt the social part of our society. Now, can we ignore? This is the pivot. In fact, without this, neither the economy will sustain, nor the security will sustain. Yes. So therefore, in fact, I am very happy that at least somebody is pushing this idea of underwater domain awareness. Because without that, the sustainability aspect will be beyond us. Because we won't understand what's leading to what. The what is called the causes of things we'll probably suffer the things without knowing what are the causes of things. So underwater domain awareness will help us understand those causes. And once we understand the causes, I'm sure the impact can also be resolved. So therefore, India is in a unique position because I have been all over the world. You see, the advanced economies have been working on this for much longer than what we think. As a result, they already have a lot of data analysis and also thinking towards how to bring that into regulation. Because they know that if the ocean health deteriorates, everybody will suffer. It will not be localized. Now, if everybody will suffer, I am sure they would not let others do things which may result in that suffering for everyone, which means through what? Global regulation. Now, if that global regulation is not fair to us, then we will end up losing. As I said, in the earlier global regulation, we have been at the losing end because we didn't have the capacity to negotiate. And in this, we want to have capacity to negotiate because this is at least no, today our situation is much different. We can invest in capacity expansion, as a result, a much better understanding of the domain, and then go to the table and say, look, this is our view on regulation. So for example, European Union suddenly brought carbon tax. Oh, come on, for God's sake. We will be losers in this whole process. There may be more regulation. Yeah. They have the pollution regulation. They won't allow your ships to dock at their ports. What will you do? So finally, we will be in a trap where we would neither understand nor will have a say in the regulatory framework. Right? So therefore, my submission is that we, as I say, we absolutely understand the economy and the security part. There, our understanding is much better. But the sustainability aspect, we don't understand. Nobody understands, in fact. More than invest a lot of the sustainability of the ocean behavior, ocean life. So therefore, I appreciate everyone for having paid attention to this important aspect of underwater domain awareness, because that's the only path forward. Otherwise, we will be recipient of technology. We will be recipients of the methodology and the approaches, as we have done all our life. So this is the time when we can be generators of technology. We can be generators of a regulatory framework rather than the recipients. So if we can do it, let's do it. Yes. So this is going to be, we are used to saying, knowledge economy and knowledge everything. But when it comes to underwater domain awareness, I think no other sector will compare with this in terms of its knowledge intensity. It's heavily knowledge dependent, but somebody has to do it. Yes. So Arnav, with these words, I thank you very much, because you are really doing pioneering work in this. It's going to be easy, I can tell you. I've been saying it always, but at least somebody has to show that we are doing it. And there is recognition. You went to European Union, you went to IMO, you are in touch with the American institutions, and they appreciate what you're doing. No? So because they want to co-opt you in this knowledge building process. Yes. So let's not really kind of look away from this important aspect. Concentrate on this. Of course, once we do it, we will benefit economically. We will benefit from the security viewpoint. But the pivot, in my view, is sustainability today. Thank you.
Thank you so much, sir. Thank you, team. I really appreciate Commodore AJ Singh, sir, Commodore Shishir Shirotra, sir, and all other participants who have joined us, and the team for putting up this together. And I also request all of you to join us for our next webinar on the 19th of March with NISA, Department of Defense. So kindly, we will definitely be circulating all the invites. Thank you all. Thank you so much. Mudgal sir, thank you very much.
Thank you.
Thanks, sir.
Arnab, it was a pleasure being part of your discussion today. Very, very illuminating. Thank you.
Thank you so much, sir. Thank you.
Thank you.
Thank you, Sridhar. Well done. Jay, very well done. And obviously the team, all of you. Catherine, thank you for putting it all together. Thank you.
Thank you.